In this video, we are going to cover 4.5, which is a system of linear inequalities. So we just dealt with linear equations, which were equations that had one solution, no solution, or infinitely many. Here, the learning target will be I can graph a system of linear inequalities in Desmos and state the ordered pairs that are in the solution set. So let's dig a little deeper in what that means. So a system of linear inequalities is two or more linear inequalities. Now, remember, the equal sign are going to be replaced with the inequality symbols, which are stated down here. The solution of the system of linear inequalities is an ordered pair that is a solution to all of the inequalities. Another way of saying it is a solution to a system of linear inequalities is an ordered pair that is in the double shaded area, which I know we haven't talked about shaded yet. I'm actually going to show you on Desmos what that looks like. So below is a table that shows you how to shade the graph and when to use the dotted line or a solid line. So please remember that a dotted line is like an open circle. It's a boundary. The points on a dotted line are not included. So if we had just a normal x is greater than 2, we would have 2 here, and we would have an open dot, and the line would be covering 3, 4, and it would go on forever. Now here we're dealing with a linear inequality. So we're actually going to be drawing a graph on the coordinate plane. And then it says, please remember a solid line is like a closed circle. So a closed circle, let's say x is less than or equal to 5. If we were to draw a number line, we would have that closed dot because 5 is included, and then any number to the left would be okay. It would be a solution. So it's very similar to that. Now let's discuss what shaded means. Now we are used to writing y equals, let's say 3x plus 2. That is an equation. All of these ordered pairs on this red line are solutions. That's why we can draw the line. Well, a system of linear inequalities takes that equation away, and let's say we put a greater than symbol. Then the shading happens. So this is what I'm talking about with the shading. All of these ordered pairs, every single one of them, would make the inequality true. So let me show you. Let me get the inequality back. So let's say we had this inequality. Y is greater than 3x plus 2. And I wanted to pick this ordered pair. That ordered pair would be negative 2, 4. So if I plug negative 2 into x and y into 4, or 4 into y, I'm going to get a true statement. So 4 is greater than negative 6 plus 2 would be negative 4. That's a true statement. Every single one of you could pick a different ordered pair in this red line, and it's going to get you a true statement. Let's say I pick negative 4 for the y, greater than 3, parenthesis, negative 6, plus 2. So then that would get you negative 16. Yes, negative 4 is greater than negative 16. Negative 16 is a very small number. So that's what we mean by shaded. However, if we go to this area, and let's say I pick 8, -2, this is not shaded. Let's say I want to plug that in and see if I get a true or false statement. I'm going to plug in -2 is greater than 3 parentheses 8 plus 2. So that's 24 plus 2 is 26. Well, that doesn't make any sense. -2 is not greater than 26. So that would be a false statement. So normally we would have you check these ordered pairs, but honestly, we're just going to use Desmos. Now, previously, I talked about the dotted line. The dotted line is like an open circle. If you picked this ordered pair on this dotted line, you're going to get a false statement because it's not included. So this is 0, 2. If I plugged in 2 into the y, and then I solve for it, 2 is not greater than 2. It's a false statement. Now, if it was equal to, then totally it would be true. But since it's on a dotted line, it is not a solution. And we can do this for any inequality. So right now I'm just making some of these up. Let's say I choose a less than or equal to 2x minus 3. If I choose an ordered pair in this shaded area, I'm going to get a true statement. This would be 6, 2. If I plug that into my y value, 2 is less than or equal to, and then plug in my x. So that would be 12 minus 3 is 9. Yes, 2 is less than or equal to 9. So I can shade that. And once again, you could pick any single ordered pair in that solution, in that shaded area, and it's going to get you true. It's the same thing because this is a solid line. Remember that equal sign. That equal sign is making all of the ordered pairs on this line true. So right here, that would be a decimal. Which ordered pair would work? This ordered pair is -2, -7. If we make this ordered pair, we would have -7 less than or equal to 2 parentheses -2 minus 3. So 2 times -2 is -4 minus 3 is -7. Yes, because of this equal sign, that's a true statement. Now, if you go to the other side where all this white space is, and you pick any ordered pair, let's pick -6, 4, you're going to get a false statement because it's not a part of the solution set. So this whole shaded area means every single one of those ordered pairs is an answer. So let's put -6 in. So the -12 minus 3 is -15. 4 is not less than or equal to -15. So that's why it's not shaded. So every single ordered pair in this red shaded area is an answer. So on and so forth. So I just picked one of the examples. Now in today's lesson, we're going to do two inequalities at once. That's why it's a system. And for it to be an answer, it needs to be in the double shaded, which we will talk about shortly. So let's move on to the next slide and let's do a matching activity. So this matching activity, I recommend putting like maybe all the symbols first. Doesn't matter. All right, remember when it's pointing to the right, it looks like an alligator mouth. So those are the greater than. When you have the equal sign underneath it, that's greater than or equal to. So then this one must be greater than. And then the one that looks kind of like a less than symbol, or an L, I guess, is how I remember that it's less than symbol. So there's no equal sign here, so it's just less than. And then there's an equal sign under there, so then that's less than or equal to. Now the new part. The new part says, if you see a solid line, like right here, if you see a solid line underneath the inequality, then you know you're going to be graphing a solid line. So I'm going to put a solid line. If you do not see an equal sign, that's a dashed line. Then the less than is going to be a dash, and then the solid line, because I see a solid line. So in this slide, we are actually going to use Desmos to graph the inequalities. So notice that it looks like in slope-intercept form, but instead of an equal sign, we have the inequality symbol. So the inequality symbol is just going to shade for us. So we have the greater than symbol in the first equation, so we're going to shade above the line. We have the less than symbol, so we're going to shade below, or the less than equal to symbol, so we'll shade below. For this lesson, Desmos is going to do that for you. So if you remember that greater than is above and less than or less than and equal to is below, that's fine. If not, let Desmos do the work for you. So it says, what kind of line is represented by y is greater than 2x plus 6? So let's go to the next slide and let's graph that. So y is greater than 2x plus 6. Now we actually want to look at the specific line. Notice that Desmos actually gives you the dotted line. So that's what we're asking for. It's a boundary. It's a boundary because of the inequality symbol. Since there's no equal sign, that means those ordered pairs are not solutions in this inequality. So all you need to do is say it's a dotted line. You can even say dashed. So it depends how you say it. Either or is acceptable. And then the second inequality, y is less than or equal to negative x minus 1. So to put that into here, we hit y, the less than symbol, and then you have to hit the equal sign next, and then it automatically does that for you. Now, if you notice this inequality, it actually is a solid line because it has that equal sign underneath it. So once again, Desmos will do that for you. So that means every single solution or every single point on that line, on that boundary line, is a solution. It's included. It's like a closed stop. So go back to slide number 5, and you can say it's a solid line. Now let's actually get into the system. So once again, let's see what happens. We have y is greater than x minus 3. So let's see what kind of line that is. So we have y is greater than x minus 3. Once again, since we used a greater than symbol or less than symbol, but in this case greater, it's a dotted line. And now we have x is greater than or equal to 6. So this would be one of our special cases. It's a vertical line, but this time it's an inequality. Make sure you type the right letter. So we have x is greater than or equal to 6. So we have the greater than symbol, and then we have that solid line. So then we have a solid line. All right. So finally, a system of inequalities. That is when we have two or more inequalities graphed on the same coordinate plane. In Algebra 1, we will only deal with two of these inequalities. Now notice that these inequalities, I'm asking you, we have this dotted line, and all of this is shaded red. So that is the solution set, or all of the answers to that inequality. Well, we have another one that's graphed. We have this blue one that's graphed. And this blue is all of the solutions for that inequality. Now, the nice thing about when we have a system is that we are looking for the double shaded area. In this case, where the red and the blue meet. That is where all of your answers are. So I don't have a cool purple. Let me see if I can get purple, because blue and red make purple. So your ordered pairs, any ordered pairs in this double shaded area would be correct. Now it says the blue point in the graph is not in a solution for the system. When it's blank like that, when there's no shaded, that means it is false for everything. In order for it to be a solution, it has to satisfy both equations. So that's where that double shaded comes from. So I can put the ordered pair anywhere in this area, and that would work. So I have 130 students. You could put this in 130 different locations. Every one of you could put it somewhere different. You could get 7.4, 3.78. That is an answer. You can get 5.06, 5. That's an answer. It has to be in this double region. If you move to the red, that is not a solution to both inequalities. If you move it to just the blue, that is not a solution. If you move it to the blank area, not a solution. It has to be in this double area. So any ordered pair in this double shaded area is an answer. Now we're going to graph and identify a possible solution. Now remember, every single one of you could choose a different ordered pair. So I have y is greater than negative 2x. plus 5. Notice it has that dotted line. Note it's shading greater than. Y is less than or equal to x minus 3. We want to find the double shaded. That double shaded is where these overlap. Now, I highly recommend you do not pick an ordered pair on the line. Yes, if you pick an ordered pair on this line, it would be a solution because it's a solid line. If you picked an ordered pair on this line, it would not, because that's a dotted line and that's a boundary. So I have always told my students, don't even go near the line. Pick an ordered pair. And make sure that you write it x comma y. So for example, 8 comma 0 is a solution. I could pick 6 comma 1, that's a solution. I could pick 4 negative 2, that's a solution. All of those are answers. The reason why they're answers is because they satisfy both of the inequalities. You would get a true statement if you plugged in those numbers. For example, 6 comma 1. If I plugged in 6 comma 1 into this inequality, I'm going to get a true statement. One is greater than negative 7. True statement. If I put it into the blue inequality, y is less than or equal to x minus 3. If I put that same number, 1 is less than or equal to 6 minus 3. Yes, 1 is less than or equal to 3. That's a true statement. So I get two trues. That is why any one of those ordered pairs would work. So in the previous slide, I could put 6 comma 1 because I just tested it. Now I'm not asking you to test it. I was just showing you in your notes. You don't need to do that part on an assessment or on an assignment. We're just asking you to identify an ordered pair that is a solution to the inequalities. All right, let's check this one. So it says, given the following system of inequalities, are the ordered pairs a solution? So let's check. We have y is greater than 1/3. Make sure you move the cursor over for the x. Plus 1. And then it says y is less than negative 2x minus 7. So the first ordered pair we're talking about is 0, negative 1. So 0, negative 1. That is in none of the shaded. So that would not work. We are looking for answers in this area because this is the double shaded. Let's look at negative 3 comma 2. Negative 3 comma 2. No. -3, 2 is not in the double shaded. So that would not be a solution. Now let's go back to the previous slide and write down our answers, and then we can answer part C. So it says, is this a solution? No, it's not, because it's not in the double shaded. -3, 2. It was close. It was in one of the shaded, but it's still not because it needs to be in both. Now let's look for -8, 2. Now -8, 2. If I go left 8 and then go up 2, yes, this is a solution. This works. If I plugged in -8, 2 into both inequalities, I would get a true statement. I would get a true statement. You don't have to do that true statement. You can just see this area right here. And this area goes on forever and ever. If you zoomed out, you could see more of that double shaded area. So -8, 2 is a solution because it's in that double shaded area. Now I forgot to put the type box, so I can just write it. So this is yes, because it's located in the double shaded. Notice that I'm talking about the double shaded every single time. So moving forward, this is a short topic, and honestly, we're just going to have you graph on Desmos and then determine if an ordered pair is a solution or not, or you get to decide which ordered pair you want to write. For it to be a solution, remember it needs to be in the both shaded area.